Okay. So today we will finish the memory architecture, and we're also going to talk about memory ecosystem and electronics ecosystem in India. Then there are two topics which are remaining. The first one is superscalar processor, and the next one is multi-core processor. Now we will finish this fairly quickly because both superscalar processor and multi-core processor has the same problems and the same characteristics as we have discussed about inline processor. The only difference in the superscalar processor is that it has got parallel execution. So that means more than one instruction could be in execution stage. And that brings in its own problems. So for example, say instruction number 7 can finish execution before instruction number 5. And then what to do about it, and how to enter the final answer into register file. So those are the points of discussion. Rest of the problems of the inline processor are there, and this is an additional problem in superscalar processor. Now in multi-core processor, once again, it is made up of a number of superscalar processors put together. So again, all the problems of inline processor plus the problem of superscalar processor plus the problem of cache coherence is there. So only new thing in multi-core processor is the cache coherence. And we are going to see what cache coherence means. We are not going to spend too much time on that because these are fairly advanced topics. So I will give you an idea what these things are. And in future, if you take a course in advanced computer architecture, then you can learn more about it. There are many, if you are really, really interested in these topics, then there are a number of interesting articles and literature which is present, and you can take a look at it and probably learn much more about it. Even your textbook has got really in-depth analysis of these two topics. So if you want to read it, you are most welcome. In fact, I would be very happy if you read it on your own. So today, let us wrap up what we started a few lectures ago. So let me share. Okay, can you see the slide?
Yes, sir.
Okay.
Sir.
Yes.
Sir, could you share the material response sheet of mid-semester exam?
Yes. It will be shown to you this Friday. This Thursday in the lab.
Okay.
It will be sent to you, but it will be discussed during this Thursday lab. Okay. Any other question before we start? Okay. So we discussed about cache design. We just to refresh your memory, we discussed about first of all why cache hierarchy, or sorry, why memory hierarchy is required. We talked about two principles. First, the temporal locality and spatial locality in our programs. I should say in our well-written programs. And because of that, memory hierarchy becomes a very helpful phenomena. If you write a badly written, if you write a bad program, which is jumping all over the place, then I can assure you that memory hierarchy, instead of helping, it would be harming the performance. So that's what we discussed. And then we also discussed the various types of cache. You can have direct map cache, you can have set associativity, you can even have fully associative cache. We also discussed about indexes. We discussed about tags. And then, we discussed about blocks. We discussed about what should be the block size, how big should it be. Then, also we discussed about block size is also known as a cache line. So, cache line and block means the same thing. Then, there are, finally, we discussed about average memory access time, or AMAT. That means that, when you are trying to access a particular, say, we discussed that, in our 5-stage pipeline, 2 stages are accessing instruction memory and data memory. So in a 5-stage pipeline, the fetch stage always accesses instruction memory, and the 4th stage, which is the memory stage, it always accesses data memory. So then, we discussed about average memory access time, because now you guys must have realized that, the biggest roadblock to the processor performance is cache misses. And cache misses are very expensive, because, even if you have to go from L1 to L2 cache, there is a 10-cycle penalty, as opposed to what you saw in, say, raw hazard, the penalty is only 1 cycle. So a proper design of cache and proper design of memory management and proper design of your program, so that, it takes full advantage of a block which is brought in. We also looked at one practical example of matrix multiplication, where the data is stored row-wise. And if the matrix size is huge, then, you saw what problems can arise, and, how performance can be sort of hampered. Now, one last thing I would like to show you is this. This is a very important figure. Now, applications and their mathematical foundation. Now, you guys might be wondering why we are studying mathematics so deeply, or why should I care about understanding mathematics? So on the right-hand side, you see the 13 fundamental mathematical algorithms or problems. So finite state machine, combinational, graph traversal, structured grid, dense matrix, sparse matrix, then FFT, dynamic programming, n-body problems, so on and so forth. So these are 13 fundamental mathematical problems or algorithms, and these are the practical applications. So as you can see, let us take a look at this thing, which is known as machine learning. In machine learning, thing, which is really hot, as you can see, this is the most useful and this is least useful. So when you talk about machine learning, matrix multiplication is one of the most important aspects. So dense matrix as well as sparse matrix, so matrix multiplication is a fundamental thing. Also, when you talk about, say, image processing, again, that is the dense matrix problem. So in your images and, even in your music, speech, your dense matrix is one of the most important things. So that's why people spend so much time in understanding proper algorithms for matrix multiplication. At the end of this slide set, though I'm not going to hold you responsible for knowing it, I have put it only for information purpose. There is a block matrix multiplication. There is a topic of block matrix multiplication. That is, again, slightly advanced topic. So I'm not going to hold you responsible for it. But, if you are interested in it, you can look at those slides that, I've also given a reference of a YouTube video. You can take a look at it. They have nicely graphically explained that, why you should have block matrix multiplication, because, it improves performance manyfold. So this is now, your problem is very clear, and probably it should also tell you. And, in all this AI and ML, they are making accelerators, and they call it neural engines. So Apple calls it bionic chip, and then they call it, they have put the AI chip in it. Then, so does ARM, that they call it ARM-MN or ARM neural network and ARM chip for AI. And everybody, in fact, there are 150 companies which are working on AI accelerators. And all AI accelerators are basically working on quick matrix multiplication. So that's all they are spending their energy on. I think someone's mic is on. If you can, Rajdev, you can turn off your mic, please. So as you can see here, that this particular idea about dense matrix multiplication and sparse matrix multiplication, probably if you don't know the difference between what is the dense matrix and sparse matrix, the only difference is that in sparse matrix, there are a lot more zeros, whereas dense matrix has like a lot of non-zero data in it. So they make basically accelerators or hardware. They use RTL, that is a hardware description language like Verilog, and write a code which can write a nice, which can implement a nice algorithm for matrix multiplication. And they put that along with your CPU. So just like GPU is in graphics accelerator, now they are, and it is quite interesting that DSP also does good matrix multiplication, because as you can see, speech, DSP, that is digital signal processing, is mainly concerned with speech. And that also requires dense matrix multiplication. So that also has matrix multiplication hardware. Similarly, graphics, that is image processing, also has requirement for dense matrix multiplication. So that also has good matrix multiplication hardware. And then your CPU, general purpose CPU, that also has a mechanism for doing matrix multiplication. And now we are talking about AI chip, which also has hardware for matrix multiplication. So then the natural question would arise that even your CPU can do matrix multiplication. And in AI thing, especially, I don't know whether you know about artificial intelligence, but there are certain layers, and each layer has got certain weight associated with it. So if you want to separate out whether this particular figure is a dog or a cat, then what it does is it breaks down the image into n number of parts. So it's like someone taking a scissor and cutting up the picture of a dog in say 10,000 parts. And then each part has got a weightage. So it may have some curvature of the ear, or shape of the nose, many different things, or shape of the tail. And then it assigns certain weightage, that if the shape of the tail is like this, then the weightage of it being a dog is higher than the weightage of it being a cat. So basically that weightage determination is done using matrix multiplication. So the whole game, if you break it down of AI, it comes down to fast matrix multiplication. So as I said earlier, all four of them can do matrix multiplication. So why do you need a separate AI chip? Because till now, your graphics processor was good enough for doing AI thing. You must have heard of NVIDIA chips, and NVIDIA chips were used for AI application. That basically it's matrix multiplication. So you use the hardware of graphics chip. In slightly less expensive system, you may have just DSP. So you can use the hardware of DSP for doing AI calculations. And if you are making, say, some kind of edge device, which has got only a CPU, like you are using, say, Arduino board, small boards which are available in the market for 2,000 rupees, 3,000 rupees, or it may have NXP chip on it. It doesn't have luxury of, say, AI chip, or having a graphics processor, or having a DSP. So in that particular case, your general purpose CPU can do matrix multiplication, right? So I mean, it is not necessary that you have to have DSP or GPU, but the final outcome would be a little slow. So then, you have to decide, because, one of the projects my master student did was he chose applications. So the applications were, image classification, speech classification, voice classification. Then on the other hand, he took several boards which has got different types of processor, that is ARM Cortex M0, ARM Cortex M3, ARM Cortex M4, ARM Cortex M7. And then, he used various neural network algorithms like, CNN, DNN, LSTM, and, there are many. I mean, if you don't understand what these are, then you don't worry. I mean, they are basically frameworks for doing calculation. And then, he mixed and matched them. And then, found out a matrix that, you can do, say, voice classification or image classification using all 4 processors, using all 6 types of neural network algorithms. But then, the problem is that, if you want to reduce the power consumption, then this particular board, which has got a Cortex M0 processor, and say, just for example, say CNN would be the best combination, but it will take the maximum amount of time, say 1 second. Whereas a combination of, say, DNN or LSTM with Cortex M7 is going to take least amount of time, which might be in milliseconds. But, its power consumption would be high. So then, you would start deciding that, okay, what is acceptable to me? So it is not that always the fastest solution is the best, because, fastest solution could be A, power hungry, and B, expensive. And, it all depends on what kind of thing, you are designing. If you're designing something which has got interface with human, then, 1 second is not too much for us. We don't think it, because, blink of an eye is few milliseconds. So 1 second is nothing for us. So we don't mind, if it takes 1 second instead of, 10 milliseconds. So that is perfectly acceptable to us. And then devices, you can make it cheaper. And, you can also make it less power hungry. So that means it can run on a button cell. So this particular figure connects your theoretical knowledge about mathematics, your knowledge about hardware, your knowledge about electronics, where how much power will be used, how much, how many cycles it would take, and the knowledge about application or programming. They all come together. So once again, I would like to emphasize that, just doing pure computer science is not good enough, because, pure computer science people don't know much about power or power consumption. And nowadays, if you write a program, which is very good in performance, but, is using up too much power, then, it would be rejected. That, it drains, what they call it, that this app is draining your battery of your mobile. And, people usually don't download it, or if they have downloaded it, they kind of remove it or uninstall it. So to make a nice, successful program, you need to have a 360-degree knowledge, which involves hardware description language, mathematical algorithm, and computer science things. So if you just say that, I want to concentrate only on computer science, then in real life world, I mean, it may be great for doing PhD, but, if you want to have a real world experience, then all these topics which you are studying right now in your curriculum are important. Okay, does anyone have any question? Okay, so moving on. This is your CPU, this is cache, and this is DRAM memory. Once again, this is just a general simplified figure. Now, you have got 1 word wide bus. So that means it would take, I mean, we have already done this problem before, so that, what is the width of the bus, how it would help in quicker communication. So in 1 word block, in 1 cycle, you can send 1 word. That means your block is just 1 word. So, word and block are synonymous. So this is like, bytes per memory bus cycle. So this many bytes can go. And then, if you have 1 word wide bus and 4 word block, then, you can do that, overlapping things. And then, these are the bytes per block. These are all self-explanatory. So I would let you take a look at it. And if you don't understand it, then, the next class, you can ask me. And we have already talked about performance of loops and arrays. And in fact, we did a problem based on this. And this is matrix multiplication. Matrix multiplication, I leave it to you. It will not be asked in the exam, but if you feel that, you want to understand this problem in much more detail, because, I have emphasized that, matrix multiplication is one of the most fundamental things in graphics and in artificial intelligence and machine learning, then probably you may want to see how it happens. So this is a nice video. I've given address and, how much time it would take. And then, this is 2D multiplication and improving reuse via blocking. That means what we originally did was, in our problem, was a naive matrix multiplication. So, like what we studied in high school, that, how do you multiply two matrices? But, this is cache blocking. So, take a small area of a large matrix and collapse it. And, you keep on collapsing it till the matrix itself becomes smaller. And then, it's like sort of divide and conquer thing. So you can take a look at this. Once again, I won't hold you responsible for this material for exam purpose, but if you have interest, you can take a look at it. So before I conclude this, does anyone want to ask any question? Okay. So let me go with another, the last topic about discussing about various memories. So okay. So let us take a look at this. The memory and electronics ecosystem. Now, I told you earlier, and that, memory
Hello? Hello? Okay, can you hear me now?
Yes, sir.
Yes, sir.
Okay, fine. Okay, so I will have to sit wearing the headphones. Okay, so memory ecosystem in India. So these are the major companies which are making memories. The biggest one is Micron, and you must have used Micron memories. Then Samsung, then SanDisk, SK Hynix, then Toshiba, and Intel is still making memory. Now, interesting thing is that all these, most of these companies have their manufacturing in Japan. And, when, you had the tsunami in Japan, the memory prices suddenly shot up. So it is because that, all the major companies, SK Hynix, Toshiba, and some other manufacturers, they have, and plus some small fabs which create this thing are based in Japan, and that part of Japan where the tsunami started. So these are the top players in the memory market. Now, these are the types of memories which you have. I think we already talked about that. This is basically the fastest is SRAM, which we are using, say, for cache, designing cache memory. And this is the access time, and you can see the price. DRAM we used mainly for main memory. And of course, the difference between SRAM and DRAM is that DRAM requires periodic refreshing, because you can think of each individual cell of DRAM as a capacitor. So a charge capacitor is given, say, a logic value of 1, and discharge capacitor is given a logic value of 0. But then, the property of a capacitor is that it's a leaky thing. So even if you fully charge it, the charge slowly starts coming down because of the leakage. And then, after a while, if you don't do anything, it will be totally discharged. So it requires periodic refresh. So that is the problem. And so it's known as volatile memory. And this basically is non-volatile memory. Then you have got flash memory. Now, flash memory has become extremely popular because, you can see the universal thing. Each one of us carry this USB stick, or, we have got SSD drives. Okay, Kudeep Singh, you need to turn off your mic. Okay, so you have got USB stick, SD card, or SSD. They're all example of flash memory. Does anyone know who designed flash memory? Which was the first company to come up with flash memory? Kuldeep Singh, please mute your mic. Okay, does anyone know which company made the first flash drive? Okay, the answer is Toshiba. Yes, I think someone got it. It is Toshiba. In fact, Toshiba is one of the most innovative company. Very recently, it was put on block for sale because it was consistently making losing money, and people or companies tried to put up a whole lot of money to buy Toshiba because of its patents. This is one interesting thing in electronics companies, and I will talk to you about electronic system, and patent is also something I will also touch upon in this particular topic, that companies a stash or whatever patents they have created is considered as a valuable commodity, because you can block others from doing the same thing. Apple is master in it, and so is Samsung, and they both keep on fighting with each other regarding infringement of this patent and infringement of that patent, and the companies are constantly suing each other. And sometimes they make patents for a defensive purpose. So for example, Samsung may create a stash of patents only if someone sues it, it can sue them back, because all of them might be one way or the other doing some kind of patent infringement on each other. So that brings us to a very interesting possibility for you students. In US, when I was studying, and it is still the case, there were a lot of big lawyer firms which would come for recruitment of engineering graduates, and especially those in the area of electronics and IT. And they were made into patent lawyers. So patent lawyers work in two different ways. The first one is, let's suppose you made a very nice device, which would do matrix multiplication very fast. Now in patent, you cannot patent an algorithm or mathematical formula. I mean, that is not allowed worldwide, but you can patent the implementation of it. So let us say you are a good engineer and you have done implementation. Now you have to write down a document, a kind of a legal document to be given to the patent office to claim as your invention. So there is a whole host of people. So in fact, companies have got a huge legal department, each company. So they are the ones, who collaborate with an engineer, and then, they understand the process and then write a patent. It helps a lot if the lawyer also has a degree in engineering, because, then they talk the same language, and, it is easy for that person to understand and how to give a legal framework to it. I mean, a person can be a lawyer, with a liberal arts background, but, then, that particular lawyer would have a hard time or tough time understanding what an engineer is saying. In fact, the legal department has a very big stranglehold over company. I remember when I was in ARM, you had to take permission from the legal department to give a talk or a speech in any public forum. So basically, you have to first create your PowerPoint slides and send it over to the legal department. And then, if legal department okays it, then only you can give a speech. So sometimes it happens that, when you call a speaker from industry, that person may be knowing a lot, but, he's not allowed to say many things. So he will give you a canned presentation, which has been approved from the legal department. So for you, the one thing for you to consider as a career is being a patent lawyer. I mean, it is still in a very nascent stage in India, but, in US, it has got a huge implication and, a huge potential. So that is one thing, which I wanted to say. I think we come down to this topic from talking about flash memory and, how Toshiba has developed it. And then, finally, your hard drive. And, when I say hard drive, I would like to say, I'm talking about hard drive, which is made up of tapes. Old technology now, SSDs are replacing this, your tape-driven hard drives. It's much faster and safer. and they're less disaster prone. Now, flash memory was invented by Dr. Fujio Masuoka from Toshiba. He designed both NAND and NOR memory. Now, NAND memory or NAND flash is much more compact and cheaper than NOR. So all your this devices that you see, the small, say 16 GB or 32 GB or 64 GB, or now even up to 256 GB, you have the small USB sticks, and they don't cost much. They're all made up of NAND gates, so it is known as a NAND flash. The only problem with that particular kind of NAND flash memory is that you have to bring everything block by block. So it will come as one block after the other, and it will only come serially. Now, for your purpose of storing files, storing music, storing videos, you don't mind that. Because, in a song, you don't want to listen to line number 1 and then, line number 10 and then line number 16. You want to, in a song, you want to go serially. Similarly, your Word file, you want to go serially. You don't want to randomize it. So for those purposes, NAND memory is very good. It's very cheap. It's very compact. But if you want to use, say, a flash memory which can replace RAM or even cache in some cases, then you have to use NOR flash. Now, NOR flash is not as compact as NAND. It is more expensive, but it allows random access. So you can see that, in very, very small, tiny systems, you don't have fast cache memory. You don't have 3 stages of, all you have is a small piece of NOR flash. And, you can put your kind of program into that flash memory, and, it can be executed. So in fact, you should not be looking down upon flash memory or RAM because, in speed wise, they are very slower than cache memory. In fact, in some of the boards, you have this SD cards, which you might be using in your camera as a storage space for your images. You can load the whole operating system on that SD card and, put it on that small board, which the people call it a computer on board. So it has got a small processor, say ARM Cortex M3 or M0. And then, it has got a little bit of memory. It has got other systems so that, it can work as a computer. It has also got, say, Ethernet port or wireless chip or something. So you can use that as a device, a mobile device. So for that particular thing, where you can put your whole operating system on an SD card, and, it can work fine. Same thing, you can store all your programs in a NOR flash, and, it can slowly communicate. Execution would not be as fast as your laptop or mobile. And, these systems are not meant for playing games or watching, movies or something. It has got a different purpose. So NOR flash is used sometimes in place of your RAM, or it can replace RAM, or it can replace the entire hierarchy, and you can just have NOR flash. And it would allow random access, which is required because, you have jump statement, you have go-to statement, or branch statement. So for those purposes, you do require a RAM NOR flash. This also brings in another interesting aspect. And that particular aspect is I talked about say now in memory hierarchy, or sorry, I shouldn't say memory hierarchy, but memory map. for a given processor. Now, as I told you, in 32-bit processor, you have 4 GB of addresses, right? So you can have up to 4 GB of memory. But within this 4 GB, it can divide up that it has got say 256 MB of NOR flash memory. It has got, say, 1 GB of NAND, then 64 MB or less of SRAM. So this is just for example. So that means each of this space, so your total space should be able to address your NAND, NOR, SRAM, and same thing happening in your phone. Now, phone nowadays are using 40 bits. It's using 64-bit processor. So for 64-bit processor, the addressable space, they have kept only 40 bits, not 64 bits, because 64 bits would be way too much and nobody is going to use that much memory as of now. Even 40 bit is like terabytes. So that is 1000 GB. So nobody is going to use that many, petabytes. So 1000 terabytes. So they are using only 40 bits. And in this addressable memory, some of the addresses would be pertaining to your SRAM, some of it would be pertaining to your NOR flash, and some of the addresses would be given to NAND flash. So now probably you understand that why sometimes you have got the exception which you get while you're writing your ARM program of illegal address. That's because you can store your program only, say, in NOR flash. This one is, say, reserved for your boot sector. This one is reserved for storing some different kind of data. So this space is like in huge space which is given to you. Only a very, very small slice of addresses are reserved for your user program. And if it is a multi-user environment, then each user gets a small slice. So that means that is very important to understand the memory map of the processor which you have got. You don't have to worry about it in the Kyle compiler, because Kyle compiler is doing that work for you. It is writing the initial part of the program. So what actually you are doing is you are writing only the middle part of the program, which is pertaining to your problem. Setting up of the system and everything is done for you by the compiler. So this is very important now. So now probably is the time to make connections with what you learned earlier. So this is what it is. Sometimes they just give NOR, a small board if you are using. Then they would say that all I will give you is your SD card will hold your operating system. That is something. And I have probably you would be working on boards in your embedded hardware system. And when I was teaching that particular course, you can take a small Dragon board or Raspberry Pi board or some other board, and you can download the whole operating system. Of course, this operating system is not, this Linux operating system is not as extensive as what you would use on your laptop, and which makes sense. You would be having this Linux kernel, but you will not have all the bells and whistles which you have on your laptop, which is making your operating system huge of few gigabytes. This one would not have the various kind of apps which you are downloading. It may not have LaTeX software, for which document preparation and various libraries for different languages. So all those unnecessary parts are snipped out. But what you have is a bare bone essential Linux operating system, which can be put on this SD card. And then, you can do whatever you want to do with that operating system. You can run your program. You can even put a compiler in it. You can make a small web server and transmit the data. So, one of the things you would learn in embedded hardware system is that you have some sensors connected to that board. That sensors might be sensing the temperature, heat, humidity, light. And then, that all the data would be coming to your central processor. And, on that processor, you have made a web server. And plus, you have written a small, say, program in Android, which can, transmit the data to your mobile phone. And, you also written small app in your Android. I think these experiments you can do on your own without waiting for embedded hardware EHD course to begin, because you already these things are available on the net, on the YouTube, with everything which is given. So that means you can put a system at your home, and you can check the temperature, humidity, light. You can control the lights from your mobile phone. And those things are not magic. It's a very simple thing. You can build a system from scratch, buy a small board, which is like NXP board or Arduino board, or if you want to spend a little more money, you can buy Raspberry Pi board. And you can create a system. So I mean, everything is done by you. You can customize it. So Alexa is a similar sort of thing, but it is for those people who have problem typing, or who are too lazy to type. But you can do the same thing at a very cheap cost. Okay. Now step forward. So these are the differences between NOR and NAND flash. That NOR flash is a bit cell like a NOR gate. It's a random read-write access, and this is a very important quality. This is a very important quality. If you want to use it as a regular memory to store your instructions and data, because you have to allow random access. And it can be used for instruction memory and embedded system. And NAND flash is a denser and block at a time access. So this is good for media storage. Okay, and of course, flash drive wears out after thousands of access, so it is not suitable for direct RAM or disk replacement, because in disk for hard drive, whether it is a SSD or tape drive, you require the empty mean time between failures, MTBF. So MTBF should be of the order of hundreds of thousands of operations rather than thousands of operations. So the cheap USB may wear out after a few thousand operations. Now, certain questions may have come to your mind that, we talk about certain things that, the speed of a particular, say, who decides what is in phone, in communication, what is 2G, 3G, 4G, 5G, and now people are talking about 6G and 7G, right? So G stands for generation. So what is second generation for communication standard protocol? What is third generation, fourth generation, fifth generation, so on and so forth? So there has to be a body which decides certain things. Now, standardization is something, which is every one of us should understand, because even in writing software, a standardized way of writing software is the most important thing, because, a new engineer is hired. I mean, you have your own programming style. Imagine a company has got 10,000 engineers, and each one of them write the program in their own way. Then it will be terrible to maintain it. So, in fact, there are some interesting books on programming style, and you should refer to it. and use that, because that is what the industry style is, that how to name variables, how to name global variables, how to name static variables. So you should write your program using that standardized method. So standardization is very important, whether it is software or hardware. So there is a trade association. IEEE is another standardization thing that IEEE sits together, and there are IEEE wireless protocols. So 802.6, sorry, 802.11 is the standard wireless protocol, and then 802.11a, b, c, d, e, f. There are various sub-protocols underneath it. So that protocol is very important, because based on that protocol, everyone has to design their hardware or write a software which is compliant to that hardware. This is particular thing, I wanted to talk about in conclusion. This is something, which I feel all of you should understand, that India is far behind in this race. So first of all, your question would come to you that who decides the standard, or how do they come up to a standard? I will give you a very simple example. Sony was the first one to come up with a video encoding standard. So they made two systems, NTSC and PAL. I don't know whether you still know anything about VHS tapes, but there were two things. There was a one cassette which has been recorded using PAL system, and the second one was NTSC. Both of them were designed by Sony. And probably, sorry, I mean, this is the wrong answer. I'm mistaking between Sony, Beta, and something. But anyway, forget about names. Sony designed two systems. One it kept for itself, and second one it opened for everyone. So what happened was that when everyone started using a particular thing, and Sony was making a different thing, though it was a better protocol, people started buying something which was made by many different companies, because because of that there was competition, the prices were low, and Sony prices were way too high because they had no competition. So in fact, Sony had to drop that particular thing, and they also had to start making the devices which adhere to the protocol, which it thought that it will just give it to other companies to make it. So that is the power of standardization. Nowadays, if you want to do any standardization or want to create any standardized product, like what is the standardization for DDR3, DDR4, DDR5, or there are two protocols for wireless. One is Wi-Fi and second is WiMAX. WiMAX was developed by Intel and Wi-Fi was developed by competitors. And all the companies which create this initial groundwork, they fight with each other to put their protocol as a standardized protocol. And to create this protocol, they form a committee. This committee has people from industry, people from academia, and they have government regulators. And this is a very powerful committee, because what they decide, based on that, billions of dollars worth of industry and and the future is dependent. Unfortunately, India does not find a place on that committee. Why? Because we don't have, and this has been my pet peeve, that we as Indians are very good followers. All the major international companies have their kind of operations in Bangalore or Hyderabad or Chennai or Noida. But those people do wonderful work. But the problem is, we Indians are good at doing what we are told to do, because India has not produced very few what they call is a shrink wrap product. Shrink wrap product is that from idea to execution. That let's say you conceived the idea of a camera or a new kind of camera, and you produce it and you sell it in the market as a marketable product. That is called a shrink wrap product. We Indians are very poor in thinking. So at least I'm doing my part. I like my students to think out of the box, not follow the, whatever is going on, I would do the same thing, because, by doing the same thing, you are not going to produce anything new. To produce something new, you have to think out of the box, come up with a different style. And, that can be done at a younger age when you are ready to question everything. When you reach my age, you start thinking that whatever was happening from before is like gospel truth, as if it is given in Gita and you can't challenge it. God-given law. And there is nothing like that. So industry commissions like JEDC, IEEE, other things are very important. If you guys try hard enough and come up with the new things and new protocols, probably you get a chance to sit in a committee which is forming standards. Okay. So this is, once again, it is self-explanatory. You can, this is again about memory architecture or hierarchy. I have told this to you, so you can, again, read this. Now, the second thing which I wanted to tell you was, I think I have shown this slide earlier to you. And that is important one, which is known as global value chain. And this has become very important in the time of COVID. We have got a huge problem, or what we call as chip shortage. That's why your car production has cut down by 50%. If your parents are trying to buy a car, the waiting period given to them is 6 to 8 months. There are fewer devices, new devices which are coming into market. There are certain brands of laptops, which are not available, or there is a huge waiting time. And that is all because of this global value chain. So let us say this is the global value chain for Apple phone. I mean, this is a slightly older thing. It is A10. Now it has changed to A15. But, they are using a stuff from this many companies. So Apple phone is not entirely made by Apple, nor it is totally made in America. As you can see, rest of the things are made in Korea, Singapore, China, and, many other places. So as you can see, Germany, Netherlands. So these are the processors and items which are supplied by different companies, which has got the headquarters in different nations. And even one of these things, because of, say, COVID or something, say you don't get sensors. That means you cannot make an Apple phone, because, you can't give a product which is 95% complete, right? The product has to be 100%. So the global value chain, the advantage is that, there are knowledge centers. So no one company can specialize in everything. And all the companies have accepted it. So bigger companies like Sony, Apple, they have become more or less R&D and marketing company. Manufacturing is never done by them. Like look at Sony televisions. They are not making anything, they are all getting it done from the other companies based in China, and they're just putting the Sony sticker on it. We pay premium on it because we feel that quality control of Sony would be there, and the product which is coming out under Sony brand name would have certain quality assurance. So that's only the reason we pay. So please understand there is a term, global value chain, and how it is useful. This is also very useful for getting a job, because if you know that, how many companies are working in India, and suppose if Apple is increasing the production, or, Apple is able to sell more and more phones, that means all these companies are able to sell more and more of their products, because, finally they're going into an Apple phone. So this is known as global value chain, and I want you to understand what it means. And one last topic, which is a painful one for all of us. See, this is a picture of 2009. In 2009, India was 21st in the list comparison of consumer market. Right, so USA was the first one, then followed by Japan, Germany, France, blah, blah, China, so on. And, India was 21st. In 2020, we have become the third largest consumer of electronics. And by 2030, it's just after 9 years, will be number one consumer of electronics product in the world. But what's the problem? We are only the consumers. We are not the producers. And when you are only the consumer, your money will be going out. They will not be coming in. So all the hard cash, that means in dollars, your government will have to pay to buy an Apple phone or a Samsung phone or some kind of computer or some kind of high-end television. We will be sending money out. And basically that means it would increase our budget deficit. And is it a big problem? Look at this. Our total import bill in 2012 was this much, $490 billion. Now it has gone more than close to $1 trillion. But even it does this figure, maximum amount of money we spend on importing petrol, right? 164 billion. Then gold. And then immediately following that is electronics. In 2018, electronics jumped over gold. So it was petroleum and electronics. And by 2030, your electronics goods will become the biggest item in your budget or import bill. An import bill is never good, right? That means you're giving money out. You're not earning anything, you're spending money. So what is the story, moral of the story? Moral of the story is that we have to be self-sufficient in producing electronics goods ourselves. Writing software and doing job for others is no good. It's not going to help you much. You need to design your own sort of hardware using RTL. It's again like a programming skill. The reason I put so much emphasis on learning electronics with software, even if you are inclined more towards programming, is without hardware, writing a program is impossible. Without understanding the hardware, you cannot write a good software. And if we can come with good electronics goods, then we can beat the company, and our import bill would come down. China is exporting country, right? They are earning money. We have got $100 billion trade imbalance with China. That means we are giving them money, hard-earned money, and we are taking iPhones and whatnot, televisions, laptops, washing machines, AC. What do we get? Government doesn't get anything other than taxes. You end up, using those products, and then at the end of the life you throw it away. So my sincere request to all of you is that please be part of the solution and invent something, a better software. And not only doing work for someone else, do a startup, design a good software, design a good hardware, design a good firmware, so that you can bring India up. You have been studying in a premier institute of ICT, and if you can't do it, then who else would? So this is my appeal to you, and I would like to stop at this particular point. And I hope, so this is something which is bothering me a lot. We have got association in India and with government that how can we increase the output from India, or designing a shrink wrap product. And it all boils down to our education system. Remember, I've been telling you for a long time that we as a student are used to remembering things and then regurgitating things. Up to 12th grade, we all went through that thing. I also went through that same stuff, what you have gone through. And you want to see problems, with given solutions, and you remember each and every one how to do it, and then the solution is given, and then you give the answer, and you get good marks, and then you go into a good engineering institute or good medical institute. What it does is it harms your out of the box thinking. You say that my job is to remember. Someone has given a solution, so I don't want to question that solution. I just want to say, okay, this is how it is done. I just have to remember it. When you come to college and when someone tries to challenge or give you a problem which is like, say, open-ended problem, or slightly different from what you have seen before or you have never seen before, and that is the real test of how smart you are. I do not give much credence to JEE result. Why? Because people have figured it out, so they just remember or go through 5,000 questions, remember all the answers, how to do it, all tricks and techniques, questions are gone, and they get good ranks in JEE. I'm not putting those people down, but there is one class of people, say hardworking people, can get good marks, and real genius people may not be able to get good marks because they are not good at remembering things. So I would like to stop at this particular point. You will have a lab this Thursday, and you will be discussing your quiz 1 and midterm 1. If you have any question, you can ask them. Your marks will also be shown to you. We are only going to have one final because it is not possible to do. I mean, I have checked; it's not possible to do quiz 2 and final. So final will be only one final. And yes, so we will start on Monday, and we will discuss superscalar processing. Does anyone have any question? Okay, so we stop at this particular point, and I will see you guys on Monday. Thank you very much.